Hello friends, let us solve some more examples on inverse trigonometric functions. So this is I think we have solved 30 examples. So this is 31st example, and if x is equal to 1 by 3, then the value of cosine inverse x plus sine inverse x is blank, and options are minus root 8 by 9, minus root 1 by 3, root 3 by 2, and 1 by 2. So let us solve this. Cosine of 2 cosine inverse x plus sine inverse x equal to cosine of, okay, can I write like this? Cosine inverse x plus sine inverse x plus cosine inverse x. So cosine of, now cosine inverse x plus sine inverse x is pi by 2. So cosine of pi by 2 plus cosine inverse x, and cosine of pi by 2 plus theta. So that is in the second quadrant, and in second quadrant cosine is negative. So this is minus sine of cosine inverse x, but we want at x equal to 1 by 3. So this is minus sine of cosine inverse 1 by 3, and now cosine inverse 1 by 3 we can have, if this angle is cosine inverse, so this is 1 by 3, and this side is root of 9 minus 1, so it is root 8. Okay, so that is nothing but minus sine of sine inverse root 8 by 3, or you can have minus of root 8 by 3, or you can have minus of root 8 by 9. So the answer is A here. Okay, let us take one more. Cosine inverse x by 5 plus cosec inverse 5 by 4 equal to pi by 2, then x is blank. So options are 1, 3, 5, 4. Now basically we would like to use the formula cosine inverse x plus sine inverse x is pi by 2. So here cosine inverse x by phi, we can write sine inverse 4 by phi equal to pi by 2. And so this x by phi, 4 by phi must be equal. So x by phi equal to 4 by phi, and therefore x is equal to 4. So the option is D. Okay, let us take one more example. Question is, the value of cot of cosec inverse pi by 3 plus tan inverse 2 by 3 is blank. Options are 3 by 17, 4 by 17, 5 by 13, 6 by 17. So now cot of cosec inverse 5 by 3 plus tan inverse 2 by 3. So this is equal to cot of, we can write sine inverse 3 by 5 plus tan inverse 2 by 3. But we can convert sine inverse in terms of tan inverse. So this is sine inverse angle 3, 5, and this one is 4. So cot of tan inverse 3 by 4 plus tan inverse 2 by 3. And now we can use the formula tan inverse x plus tan inverse y equal to tan inverse x plus y upon 1 minus xy if xy is less than 1. And here 3 by 4, 2 by 3 is less than 1. So that is cot of tan inverse 3 by 4 plus 2 by 3 upon 1 minus 3 by 4 2 by 3. Okay. So this is cot of tan inverse. Now this is 9 plus 8 over 12 minus 6. And so this is equal to cot of tan inverse 17 by 6, sorry. So this is cot of cot inverse 6 by 17. So answer is 6 by 17. So this D option is there. Okay. Next let us see tan of 2 cosine inverse 3 by 5 is blank. Options are 8 by 3, 24 by 25, 7 by 25 and minus 24 by 7. So now tan of 2 cosine inverse 3 by 5 equal to tan of 2. Now cosine inverse 3 by 5 is, so if this angle is cosine inverse 3 by 5, so 4 is here, so 2 tan inverse 4 by 3. Now there is a formula that 2 tan inverse x equal to, this is pi plus tan inverse 2x over 1 minus x square if x is greater than 1. So here x is 4 by 3 and this is greater than 1. If x is less than 1, then you don't need pi here. So this is equal to pi plus, okay, tan of pi plus tan of pi plus tan inverse 2 4 by 3 over 1 minus 16 by 9. Okay, so this is tan of pi plus tan inverse, and this we need to simplify. So this is 9 minus 16 and this is 8 by 3. So you can simplify this. You will be having minus 24 by 7. So this is equal to tan of pi, and tan inverse minus x is minus tan inverse x. So this is pi minus tan inverse 24 by 7, and so tan of pi minus theta, so that is minus tan of tan inverse 24 by 7. So answer is minus 24 by 7. So this D option is there. Okay, let us take one more. Tan of 1 by 2 cosine inverse root 5 by 3 is blank. Options are 2 plus root 3 by root 2, 3 minus root 5 by 2, root 3 minus 1 over 2 root 2, and root 5 plus 1 by 4. So tan of 1 by 2 cos inverse root 5 by 3. So if I assume the cos inverse root 5 by 3 is theta in 0 to pi, then cosine theta equal to root 5 by 3. This is equal to tan of, now this one is theta, so theta by 2, and we can use the standard result of tan square theta equal to 1 minus cosine 2 theta over 1 plus cosine 2 theta. So tan of theta by 2 is root of 1 minus cosine theta over 1 plus cosine theta. Now cosine theta is root 5 by 3. So 1 minus root 5 by 3 over 1 plus root 5 by 3. This is equal to root 3 minus root 5 upon 3 plus root 5. And if we can rationalize 3 minus root 5, 3 plus root 5 into 3 minus root 5, 3 minus root 5. So this is equal to 3 minus root 5 its square and divide by 9 minus 5. Okay. And so this is equal to 3 minus root 5 upon root 4, and root 4 is nothing but 2. So the answer is B, 3 minus root 5 by 2. Okay. Let us take one more. If 0 less than x less than 1, then tan inverse root 1 minus x square over 1 plus x is blank. Options are 1 by 2 sine inverse root 1 minus x by 2. Another option is 1 by 2 cos inverse x. Then 1 by 2 cot inverse 1 minus x upon 1 plus x, and D 1 by 2 tan inverse x by 2. Now tan inverse root 1 minus x square over 1 plus x equal to tan inverse, this is nothing but root 1 minus x 1 plus x over 1 plus x. Now this root 1 plus x and this 1 plus x, so that root 1 plus x cancel, so then it remains tan inverse root 1 minus x over 1 plus x. Now this is standard. You can take x equal to cosine theta, or you can say theta equal to cosine inverse x, and that theta belongs to close interval 0 to pi. So this is equal to tan inverse root of 1 minus cos theta over 1 plus cos theta. This is equal to tan inverse, this is standard formula for tan square theta by 2, and so this is equal to tan inverse tan theta by 2, and now theta is in 0 to pi, so theta by 2 in 0 to pi by 2, and so that tan theta by 2, so that we are having now theta by 2. You may even write this as a modulus sign, but because of first quadrant, that is tan theta by 2, and so it is theta by 2, and so it is 1 by 2 theta. Theta is cos inverse x, so answer is 1 by 2 cos inverse x. So this B option is the answer. Okay, next is if cosine of 2 tan inverse x is equal to 1 by 2, then x is blank. Options are 1 over root 3, 1 minus root 3, 1 minus 1 over root 3, and root 3. So cosine of 2 tan inverse x. Now if I take say tan inverse x is equal to theta, then theta is in open interval minus pi by 2 to pi by 2, and x becomes tan theta. Okay, so cosine of 2 tan inverse x equal to 1 by 2 will imply cosine of 2 theta equal to 1 by 2. Now x is in terms of tan theta, so we use the formula for cosine to theta in terms of tan theta. So that is 1 minus tan square theta over 1 plus tan square theta equal to 1 by 2, or you can say 1 minus x square over 1 plus x square equal to 1 by 2, because x is equal to tan theta, and you can multiply, cross multiplication, or say 2 minus 2x square even component or dividend also work. So this would imply one equal to 3x square or x square equal to 1 by 3, and therefore x equal to plus minus 1 by root 3, and here 1 by root 3 is there in the option. So answer is A, 1 by root 3. Okay, let us take next one. The value of tan of sine inverse 3 by 5 plus cos inverse 5 by 13 is blank. Options are minus 24 by 5, minus 22 by 15, minus 63 by 16, and minus 47 by 12. Now tan of sine inverse 3 by 5 plus cos inverse 5 by 13. This we can write as tan of, now sine inverse 3 by 5, so this is a 3, 5, and so this is 4. So we can write tan inverse 3 by 4, and this is cos inverse 5 by 13, so this one is 12. So tan inverse 12 by 5. Okay, now this 3 by 4, 12 by 5 is greater than 1. So we use the formula tan of pi plus tan inverse 3 by 4 plus 12 by 5 upon 1 minus 3 by 4 12 by 5, and so this is equal to tan of pi plus tan inverse 15 plus 48 over 20 minus 26, and so this is equal to tan of pi plus tan inverse 63 by minus 16, and so this is tan of pi, and this is minus tan inverse 63 by 16. Tan inverse minus x is minus tan inverse x, and tan of pi minus, so that is negative, so this is nothing but minus tan of tan inverse 63 by 16. So answer is minus 63 by 16. And so the option is C option, minus 63 by 16. Okay. Okay, take one more. Sine inverse of cosine of sine inverse x plus cosine inverse of sine of cosine inverse x is blank. Options are 0, pi by 4, pi by 2 and 3 pi by 4. Okay. So, sine inverse cosine of sine inverse x plus cosine inverse sine of cosine inverse x. This is nothing but sine inverse cosine of, now sine inverse x, can we write sine inverse x as cosine inverse root 1 minus x square plus same way cosine inverse sine of sine inverse root 1 minus x square. So this is sine inverse root 1 minus x square plus cosine inverse root 1 minus x square, and so that is nothing but pi by 2. Sine inverse x plus cosine inverse x is pi by 2. So the option C is there. Next, if alpha equal to cosine inverse 4 by 5, beta equal to tan inverse 2 by 3, alpha beta is in 0 to pi by 2, then alpha minus beta blank. Options are sine inverse 2 by root 13, then tan inverse 1 by 18, cot inverse 1 upon 5 root 3 and sine inverse 6 over 5 root 13. Okay. So now alpha minus beta. So this is cosine inverse 4 by 5 minus tan inverse 2 by 3. But cosine inverse 4 by 5 can be easily written in terms of tan inverse. So if this is cosine inverse angle, so tan inverse 3 by 4 and minus tan inverse 2 by 3, and this formula we know, tan inverse x minus tan inverse y equal to tan inverse x minus y upon 1 plus xy. So this is tan inverse 3 by 4 minus 2 by 3 upon 1 plus 3 by 4 into 2 by 3. So this is equal to tan inverse, this is 9 minus 8 over 12 plus 6. So this is equal to tan inverse 1 upon 18. So this is the option B, tan inverse 1 by 18.